This video describes the printout output off of the GIT RTP canister tester manufactured by Dynamic Design Pharma. What you see here is the home screen, and I have logged in as a supervisor. My name is SU1, and I have programmed into the system a set of parameters which yield a very short leak test cycle for the purpose of this video. So I'm going to go into cycle control, and I'm going to start a cycle. I have temperature stabilization active, so this and the time that it's going to go on is 20 seconds, and so the time is moving forward 20 seconds, and when it reaches 20 seconds we'll go into cycle control, leak test. So it's almost there. Okay, there we go. Automatically the system started the cycle, and it's going to go through a fairly short cycle. It's going to overpressurize to 3650, then deflate to 3550, and then start the leak test cycle. Right now it's in deflate mode. While that's going on, I can enter a canister ID. And notice that this went green to show that a canister ID information has been entered. And it's going to go through deflate to 3550, which is almost there. Now we're starting the leak test. I have programmed a very short leak test time of 20 seconds, so that's going to end very, very soon. And then we'll be able to create an output, print it out, both locally and remotely, and then I will show the printouts and the details of that. So I'm going to output the results, and as you can hear, the local printer is printing the results, and we also have a remote printer connected, so the same results are being printed there. I also have active the bitmap image printouts, so there it is. I'm going to go ahead and save that, and basically we're back ready to start a new leak test cycle. I'm retrieving the remote printed info, and this is what we create each time we print out a cycle. Notice that I have here both the remote printed information and the local printed information. The two bits of information are identical, therefore I will not go through the details of the local printed info, so I will go through this to show. Clearly there's a header that shows the system and the date and the time and the serial number of the system. The login information shows that I'm logged in as a supervisor 1 and my name is SU1. The recipe that was used to run the leak test cycle was recipe 2, and there's a descriptor on that recipe that is called short cycle because it's short leak test cycle parameters. And here's the list of all the parameters that were used. Overpressure was set at 3650, start pressure at 3550, pass-fail pressure at 3400. For the purpose of this video, it makes no difference what that is. It's just a number. Maximum inflate time was 120 seconds. Maximum deflate time 120 seconds. Leak test time very short, 20 seconds. The maximum pressure compensation value was set at 175 pascals. Also, we had the stabilization process active, yes, and the time was set very, very short to 20 seconds. Normally that's about 10 minutes. And then the allowable variation in temperature was 0.5 degrees. Here's the list of test results. The cycle number was 224, and as the test result was a pass, and the canister serial number is the number that I entered, or the descriptor that I entered, and it's test. The end pressure ended up being 3548, hardly any decay, obviously because it was a short cycle. The total cycle duration was 76 seconds, or approximately 1 minute. And was the temperature stabilization completed? Yes. And these are some process values. At the start of the test, of the leak test part of the cycle. The temperature internal was 20.01. At the end was 20.02. And the temperature stabilization duration was 20 seconds. In other words, it was not repeated multiple times, as it can happen. And the variation in temperature was actually nothing, 0 degrees. And the pressure compensation at the end of the cycle was minus 2 pascals. This number, the pressure compensation, is derived from the difference of these two numbers. So, thank you.